Okie dokie. Now, we're on 5F, question 4. Diagram shows a light inextensible string having one end fixed at point 0. This point here. And passing under a movable pulley A of mass 8 kilograms and then over a fixed light pulley B. The other end of the string is attached to a light pulley C of negligible mass. So please remember 0, which means 0G, no weight, back and downwards. Now, tension pulls A upwards, so that's T, that's T, and that's also T. T acting upwards, and then and then we have a second tension because we have a different wire. So the 2 kilogram particle is 2G going downwards. This is 4G going downwards. If we look at this system in isolation, what we can say is that the 2 kilogram particle will go upwards, while the 4 kilogram particle will go downwards. So we're going to say that this is A and B going down. Now this is relative to C. Now, next thing is, while tension S pulls the 2G particle up, actually pulls particle C down. So if you look at particle C, it's getting pulled downwards by the S value. It's getting pulled up by the T value. Okay. Show the diagram of forces acting on each pulley when the system is related from rest. Find the acceleration of pulley A. Pulley A is pulley A. Now, there's a deal with this, alright? What I need to make really clear is if pulley A gives up this much, see this much rope? If pulley A gives up that much rope, pulley C, do them separately. If pulley A gives up this much rope on both sides, so it has to be the same length. If pulley A gives up this much rope, pulley B will go down by this much rope. Two lines versus one line. So, for argument's sake, if we use regular numbers here, if pulley A drops 10 centimeters, pulley A drops 10 centimeters. That's 10 centimeters on the left, 10 centimeters on the right. Pulley C will drop 20 centimeters. So, C will always be twice A. So, if A has acceleration A, C will have acceleration 2A. Everybody cool with that? So, and A will obviously be going upwards. So, if A goes upwards with acceleration A, it gives up this much rope, which ends up being transferred to pulley C, which then ends up dropping. It will go down to A. So it's interesting to show that it has twice the acceleration. Now, please remember, it has 8G going downwards. Okay. Now here's what we're going to do. We're going to start off with the 8 kilogram mass. Force, we're going to say it's going upwards. Look at it. 2, 4. It's hard to know if it's going upwards or not. It's not a clear-cut scenario. If the roles are reversed and C was actually going upwards and A was going downwards, we'll just get a negative answer. So it's not a big deal. Choose a system and stick with it. If you chose A going downwards and C going upwards to 2A, you'd be correct, provided you're consistent in your equations. I'm just going to have this full system just going downwards. This whole system for me, I'm just going to have it going downwards, this one going upwards. All right? So, F equals MA, and it will equal tension going upwards, 2T, and its weight going downwards, which is 8g. Now, force equals ma, and in this case it will be 8a, because 8a going. Now, C has no mass, so force of C, we'll do it in green. Force of C is going. If it's going downwards, C is getting pulled down by S, so it's 2S going downwards. It's 0g because it has no weight. Weight will be going downwards, but it doesn't actually have weight. It's been supported by T going upwards. T is negative because it's in the opposite direction. So this means that F will equal 0a. And then quite simply transfer T over and we get T equals. So that's equation 2. And this one is equation 1. We have 2 equations so far. Here. Nextly, we're going to look at the 2 kilogram particle. 2 kilogram particle, I don't know whether it's going up or down. I have no idea. So I'm just going to pick one. I'm going to say that it's going down. 2a is bigger than b. So 2a is worth 10 and b was worth 7. That would be overall 3 meters per second squared. So if I say force going downwards is going to be 2 multiplied by 2a minus b. Remember, it's mass times acceleration. 2 times 2a minus b. And that has to equal, well, it's been pulled up by S. But I'm saying it's going downwards, so it's going to be weight, which is 2g, take away S. If I did this the opposite way around, and I said I want the force going upwards, in that case I would have 2 times b, because b goes upwards, and 2a would be going downwards, and then I would just say that equals S minus 2g. And once again, you end up with the minus 1 version of the other equation, so it doesn't make a difference. So you multiply across by 2, 4a minus 2b, 2g minus S. Then, so that's an equation. Okay, so that's another one. Just highlight this one here. Now it's worth taking time to check your work for these 3 blue equations. You do not want to make a mistake here. Now, for the 4 kilogram particle, it's going down at 2a and b. So force is going downwards. I'll choose a different color. Force is going downwards. It's going downwards at 2a and b. Oh, sorry, force is going downwards. And what's causing it to go downwards is 4g, because that's its weight acting downwards. Take away its tension, which is acting upwards. And then we're going to get, when we add it, it's going to be a 4 times a plus b, because remember, it's mass times acceleration. 4 kilograms times a plus b equals 4g minus s. Once again, color this in blue. Now would be a good time to maybe check your solutions to make sure that your 4 blue equations match what you have there. So that would be 4a plus 4b, 4g. Time to reread the question. You want pulley A, so you want acceleration A. You want pulley C, which is acceleration 2a. And each particle, you want a 2 kilogram particle, which is 2a minus b, and then you want the other one, which is 2a plus b. These are the answers you're looking for. So what we're going to do next is we're just going to get rid of all the extra material. And by checking my answer, I actually found out, see, 2a plus b, that's actually a 2a plus b, and that would actually be an 8a. So it's simple little errors that are going to cost you in this section. It's 8a plus 4b, it's 2a plus b downwards. So little things, if you're tired in the exam, or me late at night, as it turns out, you're going to make these simple little errors, and there, you do not want to cock them up in the middle of the exam. Okay? Makes things a lot more difficult. So there we go. Okay. We now have our 4 blue highlighted equations, so I'm just going to try and get them all together. And then we can decide on what we're going to do to get rid of them. So I see I'm going to try and get rid of T and S for a start because I don't need them in my answer. So T and S are going to be 2 of them that I'm going to need to try and target. 4 equations, 1, 2, 3, 4. 1, 2, 3, and 4. Now, I reckon what we can do here is, see the way S is in 3 of the equations. What I'm going to do is I'm going to insert equation 1 into equation 2. I'm going to get rid of that 2t, so it's going to be 2 times 2. So it's going to be 8a equals 4s minus 8. And that's going to be a combination of equations 1 and 2. Now what I'm looking at is whatever is in this rectangle. I'm thinking it's going to work nicely because I have 3 variables and 3 equations. I have a, b, and s, and I have 3 equations. So this should work out nicely for me if I manage to put it together. So what I'm going to do with equation, doesn't really matter which one I use. I'm going to use equation 4. Equation 4, I'm going to get s on its own. So I'm going to bring s to the right and everything else to the left. I'm going to get s equals, so this is equation 4 by the way, guys. Whoop. S equals 4g 8a minus 4b. Now what I'm going to do with this is I'm going to put it into equation 3 to get rid of the s, and I'm going to put it into equation of 1 and 2 to get rid of the s as well. Hoping that this will give me something to work with. 4a minus 2b equals 2g, take away s, so whatever is here, turn it into a minus, so it's going to be minus 4g plus 8a plus 4b. Bring everything from, I'm going to try and transfer everything to the right, so it's going to be 4a take away 8a, which is minus 4a, minus 2b minus 4b, which is minus 6b, take away 4g, which is minus 2g. I'm going to divide both sides by minus 2. I'm going to get 2a plus 3b equals g. I'm going to stop and check it to make sure I haven't made a mistake by subbing in the answer given the solution to make sure I'm correct. Yep, no mistakes in that one. Checked it. I'm good so far. Now the next thing I'm going to do is I'm going to insert equation. I'm going to insert equation s into the combination of equation 1 and 2. So this one here. So it's going to be 8a. It's going to be 4 times s. So 4 times this is going to get me 16g minus 32a minus 16b. And then there's going to be my minus 8g at the end. I'm going to get the a's and b's all over one side. It's going to be 32a plus 8a, which is 40a. Right. 8 equals 16g minus 8g, 8g. Going to divide across by 8. And I'm going to get 5a plus 2b equals g. What we're going to do next is we're going to solve these two simultaneous equations. Here, this one here, mixed in here. So, do this. Multiply this one by 3, by minus 2. I get 15a plus 6b. Then I'm going to get minus 4a b equals g. Then I'm just going to get 11a equals g. And a equals 1g over 11, or just g over 11. Then we find out what b is. So we're going to get a 2b equals g minus 5a. 2b equals g minus g over 11. 2b is equal to n over 11g, because that's basically 1 take away 11. And b equals 5g over 11. So 1 over 11g and 5g over 11. G and g over 11. God, lads, I made such an easy mistake there. See 5a, 5 times a, g, 5g, makes that, g, makes that 3g, because you divide it by 2. Sorry about that. G over 11 and 3g over 11, I'll just check down there, correct. Now, I have to get a and 2a, so if a is 1 over 11g, 2a is 2 over 11g. Next thing I have to get is 2a minus b. So 2a minus b, 2 times 1 over 11g, away 3 over 11g. And as it turns out, 2a minus b, I thought it was going downwards, when in actual fact, it's actually going upwards. So, because I got a negative answer, so if I get rid of all this nonsense here, what I'm basically saying is a is going down at 1 over 11g. C, oh sorry. A is going up at 1 over 11g, because it is going upwards. C is going down at 2 over 11g. However, I used 2a minus b, particle 2g. I thought it was going downwards. It actually turned out to be going upwards, because I got a negative answer for that. So it should be 1 over 11g, upwards. And finally, a plus b would be 2 times that plus that, which is 5 over 11g. We knew that one was going down. The 4 kilogram was going down to 5 over 11. Okay, guys, that's for question 4. Question